All right. Hello, everyone. Happy Friday. Let's get a few things set here. I did click the YouTube go live thing this time, so we will not have that problem this week. Let me shuffle around the chats here. Probably don't need this preview. How's it going, Beata? Happy Friday, and Dave Odessa. Don't forget about the YouTube. Yes, thank you. I believe I got the YouTube set. We are live. Thank you. How's it going to Shippu? Hope everyone's Friday is going well. Yep, doing pretty well for my Friday, and definitely echoing what Keith says. Hoping everybody's having a good day. All right. I think we are ready. Let's get going. Let me actually put this one just in the back, but stop the... that's not what we want. Stop the preview. Okay. And we got the screen up, right? Yeah, okay. So let's see. I don't actually have browser open already. These was a browser, is that? There it is. All right, so hello everyone. My name is Tim, and I go by FoamyGuy on GitHub and Discord. This is the Deep Dive program. In this program, we are looking at CircuitPython. Specifically, we're looking at kind of the nitty-gritty down inside of CircuitPython, either in the core or working with projects or libraries or infrastructure stuff, all of that kind of stuff. If you are new to this, though, and you don't know what CircuitPython is, you can learn more at circuitpython.org. This is the website for it right here. It is basically an implementation of Python that runs on tiny computers called microcontrollers. There's a bunch of pictures of those over here on the downloads page at circuitpython.org. So like this main little black chip here, this is the microcontroller. This is sort of a tiny computer that runs on this little computer board, and it's got all these different pins broken out, and we are writing Python code that runs on this little computer and interacts with these pins, generally connected to some sort of hardware. Although what you'll see on this page is that there are many different shapes and sizes of these little microcontroller tiny computers. So some of them have stuff built in, like keys and screens and knobs, screens, touch screens and things like that, alligator clips, RGB LEDs, speakers. Different ones have different stuff built in, but the common thread amongst them is that all 349 devices on this page can run CircuitPython. So we can write that Python code, save it onto there, just like a thumb drive, and it will execute the code for us. So that's a high-level look at what we're doing. CircuitPython is an open source project, so you can get involved if you're interested. I would encourage you to join us on the Discord, as well as GitHub. All of the development takes place out in the open on GitHub, and we coordinate through the Discord. There's weekly meetings and other discussions that take place on Discord all about the CircuitPython ecosystem. So get involved there if you're interested. It's an open source project, but it is primarily funded by this company, Adafruit. This is their website, adafruit.com. So they are paying the folks who work on CircuitPython, the core team that works on the project full-time, as well as some folks like me who work on the project part-time. So thank you to them, and thank you to anybody who wants to purchase hardware from them, because doing so, helps pay the bills, helps support CircuitPython development. They sell the microcontrollers themselves, as well as all kinds of things that you can hook up to the microcontrollers to interact with. So a couple of the things that I've got my eye on that are the new releases are displays. I'm always a sucker for displays, so there's a nice little square display here that has the new ribbon cable connector on it to make it easy to build into a project and not need a bunch of extra wires. So that's something that I have got my eye on, but they've got all kinds of different stuff that you can hook up and do with your microcontroller, as well as many of the different microcontrollers themselves that you can purchase from their website there. Jumping into today's stuff, what I want to look at is core displayio stuff. Last week we worked on vector IO, and that PR is merged now, so the stuff that we worked on last week is now inside CircuitPython main. I don't think there has been a release yet, so it's not like in the one that you will download, so you'd have to build from main if you want to get it. But that stuff is now in, and the next thing that I'm working on inside the core is actually an idea. I think Deshipu raised this idea during the meeting, was about changing the display.show API to instead be a property where you would set the group that you want to display on it. So let me pull up the issue for that, and then we can see what we are talking about. Or I have made the draft PR at this point, so I'll go there. And then it should link to this issue, which really explains the core idea here, which is that we used to, well, currently we have this function called display.show. You pass it a group, and it will put that group onto the display for you. The idea is to change that up potentially to instead have a property called like root group. So, display a root group, and then you're setting a group onto that property. You're setting a value into that property rather than calling a function and passing a group to it. So that's kind of like the core idea, the change. The idea is this is supposed to help make it more clear what's going on. Sometimes we see people reporting issues with their code, and they have called show a bunch of times in the main loop or something like that, expecting that that's like going to refresh the screen or something. Typically, you only need to call show once, unless you're like trying to show a different group. You could structure your program where you create multiple groups and then, show one and then change to show another one and then change to show another one. That would be perfectly legit. You could do that. You could also just show one group and hide and show, hide and reveal things within that group. That would be another way you could do it without having to call show again. Anyway, though, the point is like we try to tend towards properties when we have this idea of kind of like setting a thing into something. So making this a property, we think maybe will help make it more clear that you're not necessarily intended to just have to keep recalling it inside the main loop or something like that. So that is the change I'm working on, and specifically, I actually have a good chunk of it done. Let me get my device powered on and going here. We can actually get the camera set up as well. Because I've got the most basic part of this functional. What is left to do is a little bit of cleanup and some testing to make sure that we didn't break anything, and also to make sure that the broken cases, the cases that shouldn't work, still don't work, or don't do anything weird. So let's see, no display show. How would that change displayio for Blinka? And what about the JavaScript port? I do not know anything about a JavaScript port, so I can't necessarily answer that one. Unless if you mean the Wowqui thing, I think is maybe got JavaScript inside of it. I'm not super familiar with the Wowqui thing, but I know it exists and it runs on a web page, so it probably has some JavaScript in it. What would it mean for Blinka? Blinka, what it would mean, I don't think has been discussed, but my understanding is basically that would just mean we would make the same change in Blinka displayio. So inside Blinka displayio today, we have the same thing which we have in the core, which would be display.show. We would change it, and so the way this is being discussed is an addition for CircuitPython 8, so the ability to set it as a property starting with CircuitPython 8, and then removing the show function as of like CircuitPython 9. So it won't be gone for a while, but it will eventually be a breaking change when that next major release comes out afterwards. And I would assume that it basically means the same thing in Blinka displayio. We would basically add a property called root group that you're allowed to set instead of calling show. We would migrate all the example code that exists to use that property instead of the show function, and then come down the line CircuitPython 9 or 10 or whatever, when it actually gets removed, then it would also get removed in Blinka displayio. Functionality-wise, it is basically the same. You just would need to change your code. Once it actually gets removed, you would need to change your code from display.show to, display.rootgroup equals until it gets removed, you could keep the display show, but it's just kind of like deprecated, will be removed eventually is the idea. But that is actually a good question because, yeah, we do need to consider Blinka displayio, and we would want to probably make that change at the same time. Like, we would want it to become available as a property on both at the same time, I think, which is a good point, and we definitely want to remember to do that. So thank you for asking, actually, because I had not thought of Blinka displayio yet. So let's get the device. Do we have it here? I think. Is this running? It's probably going to crash when we load it, maybe. Yeah. Yeah, for sure. Question. For your example of having multiple root groups that switch between scenes 1 and 2, etc., we can just change the property. Yeah, that's correct. Yep, you could just set the property to a new group, and that would let you switch between different ones. So if that's how you want to structure your program or your application, where you have, like, let's say 4 different groups. I'm just making up a number. You have X different groups. Let's say 4. You can just set one of them onto the property and then change it out with another one whenever you're ready. So user goes through a menu or clicks a button or whatever, and then you can just swap it to a different group. Let's see here. Do we need to call a method to inform the code that there was a change? Nope. You just set the property, and the code will know that it changed, and it will update for you. Yeah, good question. I can show you how that will work as well, in fact. Well, right now it's a bit blurry. Maybe we can sharpen it up, and then I can show you how that would work. Oh, where'd the camera go? Is it like the video mode? Is it a new one? It's in a new one, I see. Okay. Oh boy, that's a lot of things. There we go. So I have Funhouse. Let's see what code's on here. If you have an example, that'd be amazing. Yeah, for sure. So this code, let's take this part out. Let's take this part out. This part doesn't matter so much. We can keep it in. We'll run this. So let's go back to the camera. Too many browser windows open today. So this code, let's see. Don't have one of the little wiper cloths here. Oh well. I tried to clean off my screen before, especially with this example, because this example draws like a little pixel somewhere. It's kind of hard to see, but it's right up in there. But this is, you'll recognize this example if you have done the displayio learn guide. This is basically just a basic displayio example. I'll change it up here in a minute as well. We'll make something slightly more functional. But the code that's in here right now is look up the display. We're using a funhouse, so we're just using the built-in display on the board. Create a bitmap. This bitmap is going to be the same height and width as the display itself, and it's going to have room for 2 colors inside this bitmap. We're going to then create a palette. This palette is also going to have room for 2 colors. We're going to set the first color to black. We're going to set the second color, index is 0 to black, index 1 to white. We're going to make a tile grid that has our bitmap, which we created back here, and our palette, which we created right after it. Now we have our tile grid. We're going to create a main group, which we will then, show onto the display here in a little bit. In fact, that's the next line of code right here. So this is where in the current API for CircuitPython, you would call display.show. In this future version that we're working on right here, you would say display.rootGroup equals main group. In this case, we then go append the tile grid to the root group. So we created this tile grid here. We created this main group here. We want to get the tile grid onto the main group. We have now set the main group as display.root group, so we can also access it from display.root group, right? So we can access it here, call append on it, pass the tile grid, so that we're going to add that tile grid into our main group, which is now visible on the display. This one is painting that one single pixel that I told you about. It is kind of hard to see, but right up in there somewhere, north of that smudge, there's a single pixel on. This is that pixel. And then there is the white rectangle right here. And that white rectangle is made with these two for loops right here. It's just looping through ranges of pixels and setting them to index 1. In this case, it just prints a thing, and then that's all it does. And it has a while true, so it will continue to show this forever and ever and ever. So we see our little white rectangle. We see our very, very faint single pixel there. All that is good. Let's make a second group, though, and switch to it so I can show you how we would do that. So let's say we were going to have secondary group is displayio group. So this is now another new group. It has nothing inside of it yet. For what should we put inside of it? Maybe let's make a label. So we want to label, we're going to have to go from Adafruit display text dot bitmap label import label. I think that's right. We'll see. Maybe I got it wrong. We'll see. Let's create a secondary group label. I don't know. That's kind of wordy, isn't it? But that's all right. Label. Label. I think this is what font. So terminalio.font. Text equals hello secondary new line group. Let's go scale equals 2. Do we need anything else? Let's do a color. Let's go color equals, oh, maybe green. Yeah, let's start with that. We're going to have to import terminal.io, so let's do that. Import terminal.io. Now we're going to go to our secondary group, and we're going to put the label onto it. We're also going to change the position of the label, so I'm going to go secondary group label dot. I'm going to set it with the anchor point and anchored position. Anchor point equals, we're going to do 0.5. We're going to place it by its midpoint, and then we're going to go anchored position equals display width over 2, display height over 2. Okay, so now we should have a label with some text in it inside of our secondary group. So now let's turn this back on, maybe make it like 5 though instead, and then let's go display.root group equals secondary group. So now when this runs, it will show the current thing, the white box and the white pixel. It will show that for 5 seconds, and then this will happen, and it should change to our secondary group. If we've done everything correctly, then we should see our label. I don't know if we have done everything correctly. Hopefully we have. I'll open TO here, so if we haven't and it prints an error message, we'll at least be able to see that. And then we will try it out. So let's go. Oh, right, it's only one of these keys now. I gotta get used to that still. This is the wrong thing though. This is, yeah, there we go. Save that. That's running, showing the white box and the pixel. Should be 5 seconds roughly, and then it will hopefully change. There we go. Hello secondary group. And then now it's just gonna loop forever. So it would just keep showing this one forever. You could also go back and forth. So inside of here, you could kind of do another thing like sleep another 3 seconds, and then, you know, change it back, right? Or do whatever you want. Change it to a third one. Change it back to the terminal. That's another thing that you're allowed to do. So you could go main group, and then you could go time.sleep another 3 secondary. So you could swap back and forth like this. You can really set it, you can set it as many times as you need, and you can do the same thing with the show function today. It's just that you don't have to, and sometimes we see people doing it without meaning to, really, or doing it without the need. Group already used. Okay, so this is good. I think group already used line 59. I think that's probably a bug. We need to, when it gets set to something else, we probably need to, group already used, we probably need to somehow indicate that it's no longer used. I'm actually surprised we were allowed... I'm surprised we were allowed to go back to main group. Why is main group different? Because we were able to, so we set it to main group the first time. We were then able to change it to the secondary group, and then we were able to change it back to the main group, right? We got back to this. We have 5 seconds of this, 3 seconds of this, 3 seconds of this, so we're back to main group, and then it crashes on this the second time it tries to use secondary group. Oh, label. Shoot. Label. Yes, we want to set it to the group, not the label, of course. Now it should go back and forth. Okay, 3 seconds on this one. Back to this one. Back to, okay, and then this should be able to just keep going back and forth forever. Okay, yeah. Got to make sure to use the group, not the label. That one's on me. How's it going, Evil Dave of Canada? Hello, over there in the YouTube chat. Happy Friday, my friend. Another thing that you can do is set it back to the terminal. So the default display in CircuitPython, if you don't show any other groups, will be what is called the CircuitPython terminal, which is where you can see stuff get printed. Like all that stuff that was printed on the screen there. We only saw it for a second in that situation there, but that is the CircuitPython terminal. In this case, we'll see it again after we loop through all the 3 of these, and then it'll come up once each time in the cycle. So this is the CircuitPython terminal here. And you can also switch back to that as well. So you can go back and forth between your own stuff, your own groups, your own displayio objects, and then that default terminal that just shows you the printouts. When you're retired, every day is Friday. Nice. That does sound pretty nice. I do have that to look forward to. Okay. So all of that is actually working, and to be honest with you, I am glad that we did try to put the label here, because that actually is good. That actually tells us one of the things I wanted to test, which was it should properly raise an exception if you try to set it to a group that is already in a group. And indeed that did happen. Because label, bitmap label in this case, actually does extend group as well, I believe. Does it? Maybe it extends tile grid. No, I believe it's group. I think it's group. Okay. So that is actually good. And that was one of the things I wanted to test, because one of the last things I did on this was based on feedback in the draft PR. This is the issue. Let's go to the PR. Is it? Maybe it's not. Or this is the, no, this is the PR. Yeah, move this to the internal, update the internal API to match the new way. So this is one of the last things I was working on this effort. And this is inside shared bindings display C, and I To be honest, I don't actually remember exactly where I left it. Okay, that's actually right where we were here. So, and this is one thing that is different now, is this used to get the Boolean here and then raise the exception. In fact, that's the exception we just saw, but now that occurs actually inside of this, which comes from here? Yes. It does leave open the question, though, would we want to also change this to set root group? Because basically what we've done so far is just add the property of set root group, but internally it still calls a method called show. And this is essentially just moving it one layer deeper. It used to call show here. I've now changed it based on the feedback to call set root group here, but set root group inside of here ultimately does just call display core show. So would we want to update this one too? And where this one would be in display core, which is its own weird thing. It doesn't exist in shared bindings. This is the show method in here. I mean, there are setter methods in here. We could just make this be set root group. Get grep -n. That seems unlikely. That looks a little better. So this is used in a few places. It's used in, well, it's called here, which is shared module display C. This is probably in the show method, display.show method, which still exists at this point. Yeah. So if we changed the display core method, we would need to update it here. 402 in the same file, that's our set root group. That's probably right where we just were. Yeah. Actually, this one is still calling show. Or this one is the one that is calling show. Okay, this is like the internal one. So we would need to change it here as well. E-paper display, we would need to change it inside of there. E-paper display. I had not actually looked at e-paper display at all. I don't know that I have an e-paper display. 106? That can't be right. This bindings? It's basically the same thing though, so I mean we would change it there as well. And then in display core, this is where it's defined, so this would be where we change it to necessitate needing to change it everywhere else. And then one more in 64 on the H file. It's just the declaration. No. Yes. Highlighted the wrong one though. And then frame buffer display. Where's that? Oh, frame buffer IO. It's not in display IO, which means we can't actually see it. We probably get shared bindings also. I don't know why it takes me off of that after I edit it. $105. Play course show, root group. Okay. So it's not too many places. I do think, I mean, it probably makes sense to go ahead and rename all of the internal ones to set root group rather than like half, which is kind of essentially what I have now. Like right now, everything up to the display core method is set root group, but then the core method is show. But I think it makes sense to change the core method to set root group, and then everything all the way through will be set root group, even if you looked at the code underneath display.show, which we'll leave it intact for now, that code will now say set root group inside of it internally here. Yeah. Okay, so let's try that. Displayio, display core. So it's not going to be show anymore. It's going to be set root group. Basically going to need to change it in all of these places that we just went through. Unfortunately, though, we just got to go back through them. Be nice if I could click. Sometimes these are clickable. Right now is not one of those times, though. We could copy the whole function, though. We could do this. This would be quicker, I guess. So that's 402, actually, so we're going to go up to 144 in this file. Here we're calling set root group, and so this is display.show. So this will stay existing for now, but eventually get removed. That's those two. E-paper display. I don't think I have I have a Raspberry Pi e-paper display. I don't think I have any others, though. You have the Raspberry Pi one. Yeah, I can use that. That would be calling set root group. 165, we did that one, I think. Or no, I did the H only, I guess. There, it's set root group. Got that, we got the H. Frame buffer display is the last one. $105. I guess we probably would want to offer frame buffer display having a set root group, though. And maybe e-paper display too, I guess, right? Gizmo. I have a gizmo, but it's not the one with e-ink. These ones do have refresh. Does it matter? That may not matter though, right? I don't think anything else changes. Yeah, we probably would want to change this too. I had not thought about e-paper or frame buffer displays. But I assume we would want to change their API to match, quote unquote, what I'll call standard displays. The ones like the built-in ones on the PyPortal and Funhouse. Oh, you know what I have with an e-paper display, I guess, would be a mag tag. Can I use I could like release the display and then reinitialize it, right? To test if my new version works. I think so, right? Okay, so we should. So I'll worry about adding set root group to ePaper and frame by buffer.io later, but let's see. We should. Why do we not? Did I save into this? Do I need to do this one? Yeah. Okay. So we should have no hits now. Yeah, we have no more of this. This is gone. It's all set root group now. So let's try to make a build and see if it works. Actually do that over here. Make a build. Or not? What did we? Oh. We got to do dot esp idf export shell. Yeah. Now we can make a build. Okay. Now we can copy. Oh, we need to go to bootloader. Bootloader mode on the device. Copy the thing we built to the device. That nice smudge right at the perfect angle for seeing with this camera. Okay, so it looks like it's working. I think if we had messed it up, it would have failed already on this first one here. So this is a good sign. Let's make sure it cycles through all of them correctly. You can actually see the little pixel better. There's our terminal. Oh, it crashed. When did it crash on? 59. Oh, I did it back to this. Yeah, let's put it back to the code that doesn't crash. Are there automated tests as part of the build process? There are not automated tests in the sense that nothing is like emulating a microcontroller and executing code on that microcontroller or just being a microcontroller, right? We don't have actual physical ones either. So nothing is like running code automatically on the microcontroller as part of the CI or anything like that. There are automated tests that build CircuitPython. So if we were to go and actually push a commit, so like here I've got some changes. I'm doing my changes. Whenever I'm done with them, I'm going to commit them. I'm going to make a new commit and I'm going to push it. Because the branch that I'm going to push it to is in a PR already for the CircuitPython project, as soon as I push, it's going to kick off the GitHub Actions to run. And there are tests that will build CircuitPython for every single device we support. So all 350 or whatever it was of those devices on the downloads page, the actions will build a firmware for each one of them. It won't do anything with that firmware. I mean, it will upload it, it will provide it, put it in a spot where you can go and download it later. But like it won't install it to a device and do anything with it, but it will at least make the build for each of them. So kind of yes, kind of no. Not automated testing in the traditional sense, but nothing either. There is still a lot going on as part of our integration. So this is happily cycling away. So I think we did not break anything, which is good. I think we're almost ready. I guess one thing we should do is there's a comment somewhere we should just delete, I think. Where was that? That would be around the 400 one down here, I think. Oh, group? No. Oh, okay, here it is. Set root group just calls common house set root group. So yeah, we don't need this. This is old now. It does still raise the exception though, which is good. We still want it to actually raise the exception. I'll make another build. Like, obviously, just removing a comment should not affect anything, but, you know, never be too safe, really. I'll do one more, and then I'll run pre-commit, and then I will push. And we'll also look into updating ePaper and frame buffer after that. So this built, copy it to the device. I know hardware emulation might be difficult in the near term, but perhaps you could use something like a Trinky to run additional automated tests on. Yes, there have been, yes, I will say it is a thing that is on the radar. It is a thing that has been thought about. And it's a thing that would definitely benefit us running some kind of automated tests on hardware. There have been a few attempts at solving that problem of kind of distributing the tests and getting them to run and collecting the results. But there has not been anything that is like able to support the kind of scale or that's really taken off usage, basically. So I will say, like, if you are interested in automated tests and if you are interested in helping us out on that front, like, definitely I think one of the things that that initiative needs is, right now at least, like a champion, a person who wants to dive in and really try to tinker away at it and make it a possibility. I would love to see it. I would love to see something where, so like my vision for this idea, which I think I have written out somewhere on an issue or maybe in the weeds of a meeting at one point or something. I should go back and find where I got this idea out of my head and down on paper, so to speak. My vision would be, though, is like members of the community, so me and you and anybody who wants to, can keep a microcontroller plugged into their computer and can keep a service running on their computer, keep a script or whatever running on your computer. The script will basically check in with a server that will allow it to download code to run on your microcontroller and then get the results of that code run and send it back to the server. So you could kind of set yourself up as a runner, so to speak, to run tests on microcontrollers. You'd keep your device plugged in, you'd keep your computer on 24/7, connected to the internet, all of that stuff. And then part of our actions, it would create this job for you and distribute it to the server, and then have your computer out there in the world, you know, download the code that it needs to run it, get the results that it's looking for, send those back to the server, which can then send those results back to GitHub. I would love to see a workflow like that. I think there are probably ways to make it happen, but it's a lot of work for sure. It's going to be a big thing, and it's going to take a lot of work and a lot of tinkering to get it set up in such a way that it's feasible. The other thing is, I think it needs to be super easy for someone to set up to run their stuff that way, right? Like, we need it to be easy enough that I think average users are having a chance to be able to get set up and run their own device as a testing device. It's not to say that every average user will do so, but if only the people who are like in it at the development level, like if only people comfortable building CircuitPython and really getting down into the weeds of everything, if those are the only people who can do it, I don't know that we'll have enough people running it all the time to make it work. But if we can make it super duper simple, you know, download this UF2 and then plug in your device and then run this script on your computer or whatever, right? If we can make it super duper simple for people to kind of donate their computing time and their device time to running those tests, I think, you know, I think there's promise there. I think that could be something that could really help us for sure. But it's a tough nut to crack, and it's definitely going to be a lot of work to get to the point where we even have a feasible way to set up and do it. I experimented a little bit down this road. I experimented with self-hosted runners on GitHub, where you could basically set up your own computer as a runner inside GitHub Actions. and then it could communicate to the microcontroller to like execute code on behalf of GitHub Actions. I did that kind of as proof of concept, playing around with it one day, and it did work out all right. I did later find the whole self-hosted runner thing is not necessarily recommended all the way from what I was reading after the fact, but that's one avenue. I think there's probably other ways it could work technologically as well. But anyway, that's kind of my thoughts and my ideas around the automated testing. So if you are interested in getting involved in automated testing, is your forte or just something you're super interested in, we're definitely looking for somebody who is all about that. Okay, so this is cycling away. We made a build. Did we actually install the build? I don't remember where I was. I'm gonna copy it back just because I don't know if I loaded this one or just the last one. I think I did load this one, but just to be safe, we'll copy it in. But yeah, if we could make that super easy, then we could have kind of like an army of people with devices just plugged in all the time, waiting to run tests. And so, to your point, Trinky or whatever device it is, right? Like we could have all kinds of different devices based on just whatever a person has and is willing to leave plugged in. So, we can actually even maybe do some hardware testing and stuff as well. Like if certain, if enough people will leave a funhouse plugged in, then we can like execute a test that's specific to the funhouse hardware. Now, it can't do everything automated either, right? There's some stuff a person probably needs to be there for, right? Like if it's, playing sound out of the speaker or whatever, right? Like it's not going to know really if the sound came out. A person has to tell it like, yes, actual audible sound did come out, but there is still a lot of stuff we could get done even without a person present. Okay, so we are cycling through here. I think we're good to go. I did erase the comment. Let's run pre-commit. Send me what you have on Discord sometime. I'd love to take a look. I will try to dig it up. I do not remember where it was at. So another initiative, I should say, credit where credit is due, Summersoft, member of the community, has not been around as much lately, but was active in the community in the past. Summersoft did work on a project called Rosie Pi and FizzaCI. This was an attempt to solve this problem. This was like a Raspberry Pi image that was made to kind of be this like middle ground. So you would plug your CircuitPython device into this Raspberry Pi. The Raspberry Pi would connect to a central server, and the central server would take jobs from GitHub Actions and then run them on, it would get them onto the Pi and then run them onto your board. So that project is out there. I would say, you can look into that, Rosie Pi. I will try to find what I did. Probably the most consumable thing that I have would be a video if I was streaming when I was doing it, and I would guess I was. So I'll try to take a poke back through my old videos and see if I can find the one where we played with self-hosted runners. It was around the time that I started working on the size measurement stuff, because I had in mind an idea of actually taking a RAM measurement on the device itself in addition to just the MPY file, which is what we have started with so far. That's as much for me as it is for you. Just remembering the timeline will help me go back and find it. But yeah, probably a video is the best thing I have. It wasn't like stuff I can share exactly because I don't remember how basically what I did is I set my own computer up as a self-hosted runner, and then I was tinkering the actions inside of the repo to call over to my runner and do stuff. Okay, we did pass all that stuff, so I will push. I don't know why we got changes in here. I did not. I don't believe that I intentionally did anything that led to this. Actually even see a change down here for this one. There it is. Okay, Pulse. Yeah, I haven't been touching anything in Pulse.io. I haven't been touching any kind of PyObj. No, did I accidentally paste? I mean, I was never even in this file, really, I don't think. File is not one that gets edited by hand. You know, it is interesting. This is also a PyObj, though. I think we're just going to uncheck that because I'm not sure what it's from. I don't think I made it. If I did make it, I certainly didn't do it intentionally. For human testing, one way to help one way to help distributed testing, if you have code and expected results, picture audio, it's easy to upload that code like the project download, then it's easy to ask others. That's a good point. Yeah, definitely. Being able to say, like, here's some code, here's what I'm expecting, you know, here's a picture or a audio recording of what I'm getting instead, right? Like, you know, if you're lighting up lights, then a video recording, or if you're trying to draw in the display, then maybe a photo or a video. Being able to say, like, here's what I ran, here's what I wanted to happen, and then here's what actually happened, and ask about it is good. So let's deal with this because YouTube is cool. Okay. Did I miss one up here? No, Discord, okay. Terminal, so we changed to that. We had a different name for that constant before. The other thing we did is change the internal API to use set root group also. Change internal API to use set root group. Whoops. Okay, we'll see if that passes, and then I guess I'll try the e-paper one. I don't... What uses frame buffer IO? I don't actually know. Should have gone to that index. I don't have that bookmarked on this computer yet. I think the LED matrix displays use it. Oh, yeah, I think you're right. What do I have that's like that? I have the 8x8 matrices, I think. Matrices. Register. This one connects to I2C. I think I recall seeing something like this, though. Is it the 13 ones? The like 7x13 or something? Star Featherwing. Is it like these? Charlie Plex. IS 31FL. Matrix as display. Does still go I2C. Let's look inside of this. That was this tablet project with an LCD display connected directly to the MCU without a driver chip. Ah. Let's see. Perhaps a better question. Okay, perhaps a better question to ask is the 80-20 rule. Where are the majority of CircuitPython bugs? The core language features or something specific to an attachment like display sound NeoPixels? The majority of bugs. I don't know if I have a good grasp on it. I would say, I think. So I would say that I think we find bugs in the core more than we find bugs in like the Python layer, the libraries. But that being said, I don't know if that's true or if that's like biased, because the bugs in the core tend to make things fail in a more spectacular fashion, right? The bugs in the core tend to make things crash or hard fault compared to the bugs in the Python layer, the libraries are less likely to do that. They might raise an exception or they might just not behave as expected. And therefore they are kind of like lesser in a way. So I don't know if we actually find more in the core or if it just feels like it because they tend to be, you know, cause more problems, cause bigger effects. It's a good question. I don't know that I know the answer off the top of my head. Bugs in the core affect more people. That is definitely true. Yeah, that's a really good point. Yeah, because a bug in the core is likely to affect not necessarily everyone, because it could be in a core module that a certain person is not using, but it's certainly way more likely to affect a lot of people than a bug in any particular library. That's a good point. With an LCD, oh yeah, the one you ran the lottery for. Oh, the hack tablet, nice. Was the frame buffer display. Okay. That's right. That is right. Maybe we can test with that. I have not built it in a minute. Would be good. At some point we want to try, I wonder, did we ever get the newest ESP IDF? One thing I was hopeful for was when we pull in newer ESP IDF, I was hoping maybe that our hard fault issue might go away, because I don't kind of reached my personal ceiling, at least for now, as far as being able to troubleshoot the hard fault. So I kind of got to just pray that it goes away in the new version. Don't know if that will actually work, but I'll have to try it out. Testing the core is easier because we can just run a bunch of Python code and have it write to the file after. Check the test results file and see if everything worked. Yeah, I would say it's probably about the same. Testing the core versus testing a library, I would guess works out pretty close to the same in terms of like how difficult it is. I really want the CircuitPython driver for this. I do think frame buffer, I do think there's something in one of these LED things that does use frame buffer though. I kind of remember this from playing with this thing one day. I have like a vague memory of something that used frame buffer IO. Maybe it's like, maybe it didn't actually use it. Maybe it just imported it or something. I was thinking there's one with a font. Is there one with a font example? Maybe it used frame buffer IO, but not as the display. Oh, frame buff. This is probably what I'm remembering. Yeah. I think this is what I'm remembering. buff. And this is not frame buffer IO, but rather Adafruit frame buff, which would be Python code, not core code. Okay. We'll have to try to figure out how we can test the frame buffer one. Does Adafruit sell an ESP32 chip that you can use Ethernet instead of Wi-Fi? I do not know off the top of my head. I do not, personally, I have not done much with ESP32. ESP32 only very, very, very recently has started supporting CircuitPython, and I spend the majority of my time and effort in microcontroller land on CircuitPython as opposed to Arduino or any other platform. So it's only been a few short, probably months, I want to say, a couple, maybe 1, 2, 3 months since we've been able to use CircuitPython on ESP32 devices. I have not tried it out yet. One thing that I would assume works, given the caveat that I just said I have not actually done anything with an ESP32, so I don't know for 100% sure that this would work. You could try asking in the help with channel. We have lots of folks who have lots of experience with Wi-Fi and with network stuff. They may be able to add more to this discussion than I could. That being said, one thing that I think could work is they do have ESP32 device. So this is a ESP32 Feather V2 device, microcontroller. And then they have a Ethernet Feather Wing. Ethernet Feather Wing. As far as I am aware, you should be able to plug this Ethernet Feather Wing in to an ESP32 or pretty much any other Feather and get your network this way. Get your network through the Ethernet cable rather than through the Wi-Fi. To the best of my knowledge, that should work. Again, I have not tried it. I am not 1,000% sure, but my guess is that would be fine. I don't know of a reason that it wouldn't. So that might be something to look into. That being said, I don't know of a device itself, like just a device that's built in by itself that has Ethernet instead of Wi-Fi. Got to hit the hay. Thanks, Tim, and good night all. Yeah, thanks for hanging out for a bit, Dave. Have a good night and a good weekend and all that stuff. Matrix LED use frame buffer library, not the frame buffer IO. Okay, it's the frame buffer from MicroPython. Made a few contributions to the ISL. Was suggested to implement PixelBuff, but I did not know how to. That was for a Pimeroni multi-pixel line. ISL. I'm not familiar with ISL as the acronym there. So I guess we'll try ePaper to start with. And basically what we would need to do is make kind of some of the changes that we made to display to this one. Doesn't have show here. Only reason I can think of is some other module also using the same pins. Yeah, that's a good point. It would be good definitely to double check on the built-in hardware on each device and make sure that the pins that the Ethernet thing is available on, I guess probably SPI. I would assume SPI, but I'm not sure. Make sure the pins that it communicates with are valid, same pin, same location on the ESP32 Feather. They tend to be pin compatible, the Feather Wings and the Feathers, but there are situations where the pins are different on different Feathers, and that can definitely cause differences. There may be jumpers or something like that that you would need to do, change or set your chip select line. So that's another thing to look out for. Just make sure that all the pins are matching up. But I would assume that it is possible to connect those together. Okay. So we pretty much want a copy of this, but it's called set root group. And I think we should probably just try to make it match the one from here as best we can. So we put this one down under bus. And to start with, I'm actually just going to grab all of this, even though like some of it's going to change. I'm going to take all of this. We're going to go over to e-paper. Is there a bus in here? Busy. Bus. Or bus. Get bus. Set rotation. Get bus. I think that's pretty much where we had it before. I'm going to put this stuff. So root group is a group. Root group on the e-paper display. Paper display. So this will be e-paper display. Split this. We can go also look at show. Oh. Wait a minute. This is the wrong place. This should be shared bindings. Thought we were in, but we aren't. This one is shared bindings. I guess I should close some of these. I don't know why the paste doesn't work right with the indentions. There's bus. Okay, yeah, this one is actually... See, when I paste it, it's no longer indented. Could run pre-commit, which has the formatter, I guess. I need to figure out how to get... I don't know why it does that, basically. I need to make it not do that. I need to make it paste with the right... Well, I mean, at worst, I would like to make it paste with the same indentions that I copied it with. Like, that'd be pretty good. ISL is the library we were looking at. Oh, ISL, sorry, the LED library. ISL F31 something something. I don't know the full name. I'm with you now, though, yeah. Pixel buff. I wouldn't even know how to begin trying to put pixel buff to it. Check the learn guide of that Ethernet feather to see the use case and the language that are supported. That's a good point too. Yeah, the learn guide for the featherwing should give you information about which, like, if it's Arduino only or CircuitPython and Arduino or CircuitPython only. It should, I would assume it should tell you about any hardware, like specific compatibilities or incompatibilities that are known about as well. So like a lot of this stuff will need to be now e-paper display. instead of display. But I don't know if everything. It looks so. There's self, like pretty much everything. Native display. So this is where to start with before I actually just was calling show in here. Might be worth doing that to start with so we can test less changes at once. So I will say my my C and my core stuff, I'm not like fully confident in the changes I make in here just yet. We did lose this e-paper. We should have a set root group now. This is in, so this is in bindings C. I do think I was able to do this from here. Let's see if it builds. I don't know. Might not actually build. I'm sure there's more that we're supposed to do. If nothing else, we didn't put it in H yet. I think we would want to do that. I suspect we should probably need some changes in shared module also. Okay, yeah. This thing doesn't exist or something. Yeah. Basically, this doesn't exist yet. So I think inside C, we need to declare this. I mean, inside of shared module C. So this basically can just do the same thing as this. Do we need it in shared module H? No show. Fine then. This one does. We'll want to make a get root group also, but I know that we're ready for it. I don't know where the code for it came from actually. Maybe this. Oh man. That's the locals dictionary table. No. Okay, here we had a get root group. Okay, we actually do have this. But this is gonna try to call this one. Does this one exist already? Ooh. I didn't actually have a get root group. See if it builds. No. Get root group. Get root group. E-paper, so inside shared bindings C 357. Should this be e-paper display? Paper display H. Ah, yeah, this should probably be e-paper. Spelled slightly differently. Previous declaration was here. Okay. Error conflicting types. So yeah, we gotta go to shared module. 46. Self. So right. This should be e-paper also. Paper. Went longer than before without crashing so far. There we go. We got a build. Look at that. Okay, we got a build for a device we can't test it on because I don't have an e-ink screen that could plug into the funhouse. So we are gonna get a MagTag build. One thing I don't know is like if I make a MagTag build, am I already testing this? Like is MagTag using this stuff internally on board.display? Or do I need to make a MagTag build and then release displays, manually reinitialize the display using the e-paper display class, and then I'd be testing my stuff? I don't actually know. If anybody else who's watching does, let me know. I will try to find the device to make the build with. So let's go ls boards, MagTag. I don't know if it's Adafruit MagTag. MagTag, there it is. Ooh, it has a dot in it. Perhaps the only one with a dot in the name. Look at that. Nice. One looks like the only one with a hyphen. It's using this internally. Okay, so if we get this on our mag tag and it actually still shows stuff, then we're in a pretty good spot. Let's find our make mag tag. While that's building, I'm gonna run and find the mag tag, so I'll be back in a second. Okay, mag tag acquired. Looks like we got a build as well. Conveniently, the plugin is in basically the same spot. No idea what code would be on here. Maybe we should take a look. It doesn't look like it's doing anything, actually. Shows an empty group. Calls refresh. Okay. Go. .730 beta 1. This is a sign that I don't use my mag tag enough. How does the bootloader work on the mag tag? Is it double tap reset? Where's reset also? Ah, yeah, it should be because we got purple. Yeah, there we go. Okay, bootloader, mag tag boot, CP build, Adafruit mag tag, firmware, media, mag tag. Got the Blinkins. You'll need to assign the root group in your code to test it though. Okay, yeah, we can do that. This one takes a little bit longer to copy. Oh, I do think it is done finally, though. Nice. Okay, so we are definitely updated now. 8.0 beta 4, plus the dirty build or whatever, right? Because I just built this from essentially starting from main a few days ago. At this point, it's probably out of date by now, but hello mag tag, that printed out, so we will make our program actually try the new stuff. So I'll just kind of do similar thing like we had before. I'll do just the label by itself for now though. From display text bitmap label import board. Anything else? Import terminal IO. Import display IO. Let's start with that. While true, pass main group equals new group. Let's go test label equals label. Terminal IO font text hello mag tag dot set no, dot root group setter. Color, we probably want white because I think the default background is black. Main group dot append test label. This needs to be display IO. Yeah, so now we would go board. Let's make display. It doesn't really matter, right? We could just use the shouty one, but let's go non-shouty display equals board dot shouty. Whoop, display. And then go display group equals main group. And then because it's a mag tag, we also have to call refresh. Also, because it's a mag tag, it has a refresh limit of like once every 5 seconds or something. What I like to do, because I find it convenient, is just put a time.sleep at the beginning of the script. That way it will never crash for trying to refresh too fast. I'm just going to go time.sleep like 3 seconds right at the top. Okay. All right, so we get our 3 seconds of sleep. ePaper has no root group. Okay. Probably we forgot to put it in the, what is this called? The dictionary of, the local dictionary. Yes, local dict table. We did not put it in here. Let's do that. I don't know if that's the right name. We'll see. Okay. Bootloader. That's not very dark gray. Yeah, it looks like that worked. One thing is my label is in a weird spot because by default labels are halfway off the display. We didn't do our anchor point like we did on the last one. Test label, anchor point. This time I'm just going to use 0, 0. Instead of centering it, we're just going to go 0, 0, and then test label, anchored position. Let's just do something like that. Oh. Refresh too soon? Is this not long enough? That's actually the exact thing I put the sleep here to try to prevent. But apparently we didn't sleep long enough, I guess. There we go. Oh, we got our label in there. And then just to make sure, let's also go Let's go 8. Make sure it goes back to the terminal correctly. Do we print something too? Yeah, let it go. I didn't call refresh, so we will. Let's print something also. Terminal time. Terminal time. It's terminal time. So this one probably won't. Oh, I guess it will refresh. Yeah, fair enough. But it didn't show anything else before it. But it should go back to the terminal now and print. Yeah, terminal time, we get to see it there as well. Okay. So we're good on e-ink. Functionality-wise. Fast. Probably hasn't been long enough that this would have actually passed or failed yet. Oh, has not even run anything yet, it's still queued. With any luck, it will cancel the prior actions and overtake them with the new one. Not positive if that's how that works, but if we're lucky, that would be what it would do. Frame buffer IO. Don't think I've cloned this yet. See if we can find a project that uses frame buffer IO. Oh, the camera just died. I know, because its light turned off. It's because I changed the background. UFO. Flying saucer, huh? Why is that the thing that was open? Doesn't it seem weird that this is the thing that it opened automatically? Why did it do that? Did I open that? Because this was a brand new cloned thing, so like it wouldn't have had any prior history or anything. There's a billion different code pies in here, all in their own folders. And it somehow settled on... I must have clicked it, right? Did I click it? I must have clicked it. Surely it did not just open that by random. That'd be crazy. Anyway, though, what we're actually looking for, git grep frame buffer IO. Also, let's do -n, because that makes it more useful. Ooh. Maybe I spelled it wrong. Hopefully I spelled it wrong. Yep, fram buffer. Fram. Good old fram buffer. RGB matrix. Okay, matrix portal stuff, maybe. And sharp display. I do have a sharp display. I do not have a sharp display that is like ready to just hook up and test this evening, though. I got one of these, I think, maybe? Something, it's very similar to this, if not this exact one. Let's look at the code. It's the code that makes it go. Indeed. Release the displays, importing frame buffer IO. Oh, it's creating a sharp memory frame buffer. Which it imported from sharp display. Ooh. Oh, but then it's making a frame buffer display from the sharp memory frame buffer. Okay. So frame buffer display would be the object we're changing. We would be changing the show. I mean, we would be leaving it alone for now, but we'd be adding the set root group that will ultimately replace show. And we'd be adding that to frame buffer display. Okay. I think this will probably be tomorrow's plan. So for folks that don't know, I stream on Saturday mornings also typically. Although I am thinking about maybe changing up the times on Saturdays. We'll see. I've mentioned that a few times and I haven't actually done it yet, so we'll see if I actually do. Definitely not for tomorrow, though. Tomorrow I plan to stream at the normal time on Saturday, which for me, for right now, is 10 a.m. Central Time. And I think what I'll work on tomorrow is I'll get the sharp display out, and I'll work on making this change in frame buffer display class tomorrow. But 10 a.m. Central Time, right back here in the live broadcast chat, that's where you can get the links to join us. I will be under my own accounts instead of the Adafruit account like we are right now. But I'll drop the YouTube link, and then, you know, it's the same link on Twitch every week, but I'll put that as well in the Discord when I get going, and this will be what I work on. So that'll be good that we can actually test that. And then it looked also like RGB matrix stuff. Oh, and the glasses as well. I have the glasses? I think I do have actually a set of the glasses. I have not done much with them yet. I think I do have a set of those as well, though, so maybe we can try that out also. maybe the matrix portal. On the matrix portal, what I don't know is is it the same as the mag tag where I can just use board.display? I guess it probably is, right? RGB matrix. Yeah, see, these are linked. I can just click this and it goes to there. But like, sometimes they weren't. Like whatever we grepped earlier, it wasn't. This makes a matrix. Oh, but then it makes a frame buffer display from matrix. Okay, so this probably behaves like a frame buffer. Kind of like the same way the sharp one made a sharp display frame buffer and then passed it to frame buffer display. Okay, cool. So yeah, we'll be able to test this one. We'll be able to make the changes, try it out on a few different platforms. What I will do is I'll put a note here about some of the latest changes and the plans on... Oh, awesome. Yeah. Hold for review, but maybe I need to not stream with this chat. Can I get... Maybe I can get a different chat window. Can I be logged into YouTube as two different users? Could I have one chat window as my user and one chat user as Adafruit user? Thanks. Okay. Now, where was I? I probably need to figure that out. If I could be my own, because like, if I was my own user, then I would not have moderator, which means it probably wouldn't show me that message. Whereas what we have here on the display is actually just the Adafruit user, which is moderator, and so it does see those. I'll have to try that for next week, maybe. Incognito is a good idea as well. Maybe we can do it without even logging in or something. Yeah, I'll have to try that for next week. Maybe we can get it to where... But I mean, I would want the moderator chat as well, I guess, in case we do still need to delete something. So I'd have to juggle another one and just keep only the lesser of the two as the OBS one, basically. Okay, let's fill in a comment here, and then I think we'll call it a night for this evening. So, the latest commits... Change the name of the constant to this and make it return the terminal group. This is already in memory. Latest commits make a few changes, including changing the name of the constant to maybe we could bullet point them just to make it clear. So what else did we do in this? We changed the internal API, changed the internal API calls to use set root group instead of show, all the way down into display core. Made this internal change for 3 types of displays. displayio.display, displayio.e paper display, frame buffer io.frame buffer display. Added the set root group property to e-paper display. Tested successfully on magtag One open, let's see, one remaining open item for sure is adding the set root group property to frame buffer display. To work on that tomorrow. Once that is in place, I think this is ready to move out of draft. State, I guess? State. Oh, we did finally start getting passes. Hopefully they're not from the first one. But still say yellow though, so I don't know. Okay. So that'll be the plan. Tomorrow I'll get find my Sharp display, get that set up on a I think it's a breadboard, the one I have, so I'll have to get some wires, jumpers ready to go to connect up to something. We'll test that out. I'll get my matrix portal as well. We'll try out the matrix portal once we make those changes to frame buffer. Once we get that in, I think this is pretty much ready to go. I mean, certainly ready for the next round of reviews, I would say. I don't know of anything else beyond that we would need to do inside of it before it's ready. I believe everything will be functional at that point once we do the one in frame buffer display. Trying to think if there's... I mean, let's go look at Sharp display. We don't need to do anything inside Sharp display, I think, because it seems like it uses frame buffer IO. Let's just make sure. Yeah, this just has a frame buffer. It doesn't actually have like a display object. Are there any other kinds of displays? So there's parallel display. Where is that one used? Doesn't seem to have all the same stuff either. This is just parallel bus. Oh, it's got its own bit of helpers. So this, I think parallel display was used on the hack tablet. It's available on quite a few. Does the PyPortal use parallel bus? I think it just still uses display though, right? displayio.display. Oh, bus. I don't know why I have this open so massive. Parallel bus. I do have a breakout which has, I think, parallel pins. Has like one option for parallel, one option for SPI. I only used it for SPI so far. Could try that. I'll have to try to look into this. I don't know for sure if this might be the deal where it's kind of like the Sharp one where technically it just uses one of the other ones. So as long as we've already made the change in displayio.display, then it might cover the usage of parallel bus. I'm not sure. I got to look into parallel bus a bit and figure out if it actually has its own display class or if it's just using the one we already changed. But we'll try to poke around a bit tomorrow into that as well. That'll be the plan. Alrighty. I will start getting ready to pack it up here then for now. So thank you to everybody who is watching. Thanks for everybody who hung out in the chat and asked questions. We had a couple of good questions about displayio stuff this week. Always good to see that. Definitely everybody always feel free to ask any questions about what I'm working on or just CircuitPython generally, or especially like displayio. I happen to have a lot of just like experience with basically, so I'm always happy to talk about and answer stuff as best I can in that realm. Yeah, thank you. We have Deshipu in the chat. Thank you, Deshipu, again for the idea. In the weeds, I think I mentioned before, this is where this idea came from. I do think this is a good evolution for the displayio API, so I'm excited to get it in and start getting some of the test code updated. So that'll be kind of the next step once we have this actually in the core and the PR is, out of draft and actually approved and merged, then we'll have to go back and start updating test code and stuff. So that'll be an effort, but we'll get all that in. And then for the next new release way down the line, then we'll eventually get rid of the show method. But yeah, thank you, Deshipu, for bringing that idea up. Again, I do think this is a good step forwards. Thanks for the stream. Really interesting edition. Yeah, thanks. Thanks for hanging out, Keith. Thank you, of course, to everybody for watching. Thank you to Adafruit. Again, if you want to help support the project, one of the ways you could do that is by purchasing hardware from Adafruit. Head to their website at adafruit.com to do that. I will be back tomorrow morning at 10 a.m. for my stream, so you can either follow me on Discord, foamyguy_Twitch, or you can just hang out in the live broadcast chat around 10 a.m. Central Time tomorrow morning. I'll drop the links in there, and we will continue on with the frame buffer display. Hope everybody has a good night, and I'll see you later. Thanks.